All right, first grade, we are on lesson number 5 today, okay? Lesson number 5 is properties matter, or properties of matter, okay? Properties of matter. All right, so what are properties of matter is the question that we're answering today. Okay, our learning target is we can identify and describe basic properties of matter. All right, Properties of Matter by Karen Jones. Scientists are people who work to discover new things. Scientists learn by conducting experiments and investigations. Making observations is an important part of what they do. When we observe, we use our senses to gain information about something. Our observations help us to answer questions and learn new things. Everything in our world that takes up space is called matter. All matter has properties that can be observed. Okay, so far we know that what matter is. We know that matter is anything that takes up space in our world. Your pencil, a car, you, okay, air, okay, and all matter has properties that can be observed. We know how to observe. We use all our senses, if it's appropriate, to observe. Properties of matter are characteristics that can be noticed, measured, and described after careful observation. Properties include things like color, shape, size, and temperature. Observing properties of matter in the world around us can help scientists when they are conducting experiments. Okay, this little scientist is observing. All right, so a little review of our states of matter, okay, is our solid, very tightly packed together, liquid, slightly less packed together, and gas, much, much less packed together there. Okay, so matter can be described first as a solid, a liquid, as a gas. Okay, so that's the first property, the state of matter. The next property that we talk about is color. So scientists can observe the color of matter. They can use color words to describe what color things are. They can observe changes in color or brightness during an experiment or an investigation. They can observe whether matter is transparent, meaning you can see through it, or opaque, meaning that you cannot see through it. Okay, so your window is transparent. Okay, my table, your wall, opaque. You cannot see through it. Okay, so we could describe what this boy has around him by saying he has one beaker that has got purple liquid and the other has green liquid. It looks like he might be trying to put them together and see what color they might change. So if he pours this purple into this green, what color is he going to make? Yeah, probably not a pretty one, huh? Okay, probably be like brown or black. All right, so scientists can observe the size of solids. They can use tools like rulers and tape measures to measure length, width, and height. Size can be measured in different units like inches, feet, yards, centimeters, meters. We'll discuss those later this year. Don't worry about them. Okay, so this girl is observing the size of her solid, and the solid that she chose is her plant. So she is using a meter stick here to measure the size. Okay, so we've got the state. Is it a solid, liquid, or gas? This one's a solid. Okay, we could observe the color here. It's green. Okay, we've got like a darker green, and then the pot appears to be like a lighter green. Looks like there might be some brown soil in there. And now she's observing the size. Okay, she's observing the size. Volume. Scientists can also measure volume, which is how much space an object takes up. Scientists can measure volume of solids, liquids, and gases. Scientists use graduated cylinders and beakers, pictured here, to measure volume of liquids. Okay, ooh, there's our bell. Doesn't apply to us. All right, so we've got graduated cylinders and beakers here. Okay, and they are measuring volume. Most often we measure volume in science with liquid, but you can do it with solids and gases as well. Okay, so when you are putting in a half cup of oil into your cake mix, you're measuring the volume there. You're getting that half cup as a measurement of volume. Okay. The weight, y'all, we have one of these. Do you remember using this? Scientists can observe weight, which is how heavy or how light something is. Okay, and weight can be observed using scales or pan balances. All right, so this pan balance is kind of what we used the other day when we were measuring. We can measure weight in different units, such as ounces, pounds, and tons, or grams, kilograms, and tons, spelled differently. Okay, so depending on the size of the object is what we would determine what we would use. So if I'm going to measure the weight of an ant, I probably don't need to measure in pounds, do I? Okay, and we don't use ounces as much, except when a baby is born. If you just had a baby born around you, you might hear, oh, they were 6 pounds and 5 ounces. Okay, but as adults, we don't really use that. We wouldn't say that man is 200 pounds and 14 ounces. Okay, we usually just stick with pounds when we're a little bit older. Okay, and then tons would be used to measure something that's quite heavy, like an elephant or a car. All right, you might hear some of that used and say that was 4 tons. Okay. All right, shape. Scientists can observe the shape of matter. Some objects are two-dimensional or flat. Shapes like squares, triangles, and rectangles and circles and trapezoids and hexagons are all two-dimensional shapes. Those are shapes that we could draw on paper in front of us. Those are two-dimensional. Some objects are three dimensionals. That means we can pick them up and hold them. Okay. And those are things like cubes, prisms, cones, spheres, pyramids, and cylinders. Those are all three dimensional. Those are things that we can hold in our hand. Like a can of peas. If you have a can of peas, you can hold that in your hand. It's not flat. Okay. You can hold it in your hand. So it's a 3D shape. It is a cylinder. Okay. If you drew the top of a can of peas on paper, it would be a circle. Okay, if you were drawing a box on paper, you might just draw a square. Okay, all right, shape. The next one is texture. Look at them touching this tree. What great scientists observing the tree there. They could talk about lots of things. They could talk about the color, brown. Okay, they could talk about the shape. Okay, they could talk about the size. They could even maybe guess the weight. But what they're talking about here is the texture. And the texture is the way that something feels. Scientists can observe the texture of matter. Is it smooth or rough? Is it soft or hard? Is it sharp or dull? Is it wet or dry? Okay, think about something around you. Touch the table that you're sitting by. What does that table feel like? My table is smooth, it's hard, okay, and it's dry, thank goodness. Okay, maybe if you have a pet, okay, go pet your pet. What do they feel like? Are they smooth or are they rough? Are they soft or are they hard? Gosh, I hope they're soft. Okay, are they wet or dry? Oh, I hope my dog's dry when I get home. All right, so go outside and measure and feel the texture. Okay, maybe inside you could feel your couch, the floor, the wall. Ooh, maybe a grown up can help you touch your ceiling if you have a textured ceiling. Okay, find things to find the texture of. The texture. Even food has texture that you can taste or feel with your tongue. Okay, texture. Hardness. Scientists can observe hardness of matter. Hardness can be determined by how easy something scratches, dents, or bends. Okay, hardness. If something is very, very, very hard, chances are if we strike it, hit it with something else, it's not going to have a mark. Okay, but that's why our cars are not as hard as we think it is. So that's why our grown-ups get upset if we hit a car door into another car because that's going to leave a dent. Its hardness is not very hard. All right. So if something scratches easy or dents easy or bends easy, it's probably not hard. Okay. If you have a piece of paper, we can dent it or bend it really easily. But if you've got a piece of very strong metal, it would be harder to bend it. Okay. Look at this can. That doesn't look like a very hard can, does it? Okay, that's why if you drop a can, sometimes it gets misshapen. This one looks like it's got pretty misshapen, huh? Okay. Next one is temperature. We talked about temperature the other day with our thermometer. Scientists can also observe temperature of matter. Temperature is how hot or cold something is. We can use a thermometer or a sense of touch to observe temperature. Thermometers can help us accurately measure temperature. We measure temperature in Fahrenheit here, or in most parts of the world, they measure it in Celsius. Okay, so if you ask how warm it is outside, so is it hot today? And your parents say, oh, it is 98 degrees out. You're going to say, wow, that's hot. But if they say, it's only 30 degrees, that's going to be cold. Okay, so we can describe matter with their temperature. Is it warm? Is it hot? Is it cold? Is it just chilly? Smell. Scientists can observe the smell of matter. Some smells are good smells, and some smells can signal danger. During an experiment, scientists can use their sense of smell to notice changes. So, good smells could be like, warm cookies in the oven, and bad smells could be a smell like smoke. If we smell smoke, we can that might be a signal that there is danger. Okay, so smell. Flexibility. Scientists can observe flexibility of matter. Flexibility is how bendable matter is. If something can bend or stretch, it's flexible. If it bends when you try to bend it, or if it breaks when you try to bend it, it's rigid. Okay, so think of a potato chip. If you try to bend a potato chip, what happens? It breaks. If you try to bend a potato chip, it breaks. It is not flexible. Okay? But if you get a piece of paper and try and bend a piece of paper, does it bend? Yeah, it does. So a piece of paper is more flexible. Okay? What other flexible things do you know? Maybe you could say you're flexible, but if you bend the wrong way, you might break. Okay? Flexibility. Absorbency. Say that for me. Absorbency. Whoa. Scientists can observe absorbency of matter. Absorbency means how well an object can soak up liquid. Matter that soaks up liquid is called absorbent. You can tell something is absorbent if you place it in water and you're able to squeeze water out of it. Okay, that's showing that water was held inside of that matter, inside of that sponge there. Okay, and you forced it out by squeezing it. If you hadn't have forced it out, it would have stayed inside of that sponge. All right, so think of things that are absorbent. Are your towels absorbent? I hope so. But think about like your table. If you spill water on your table, it's not going to absorb into your table, is it? No. Okay. We know things that are absorbent because those are the things we run for whenever we have a spill. Okay. Paper towels, kitchen towels, all things like that. Sponges, they're all absorbent. They hold water. All right. So some properties of matter can be observed using our eyesight. Other properties can only be observed using scientific tools like magnifying glasses or microscopes. So there's our properties of matters. The state, is it solid, liquid, gas? The color, the weight, the volume, the size, the shape, the texture, the hardness, the temperature, the smell, the flexibility, the absorbency. Okay. Properties can determine how matter can be changed and how it can be used in everyday life. Using our senses to observe properties of matter is an important part of conducting experiments and being a scientist. All right. So what are some properties of matter, guys? What do you think? I want you to say 2 properties of matter. Go. All right. Okay. So this is your activity. The states of matter. Okay. So your job is to go ahead and write or circle the state of matter. All right. So is this solid or liquid? Is that flip-flop solid or liquid? Okay. Is that weight heavy or light of that balloon? Down here, is this sponge absorbent or not absorbent? Is that temperature hot or is that cold? All right, good job, guys. I'll see you tomorrow.